Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Mazridha Achiri. My ID number is 2106031100007. I'm from Chemistry A, and here I wanted to tell about sampling strategy and preservation, contamination analytes, and contamination from reagent. This is from chemical environment. Okay, water and wastewater analysis. It will explain about on sampling strategy and preservation. And in this material, it will preparation of sampling and its preservation, and the tools consist of. And the second is contamination analysis. It's by contamination from the atmosphere, by the aperture, from equipment, from water. And then the third is contamination from reagent. This is explained about mineral acid and ammonia, and then inorganic solid, organic reagent, organic solvent, and the last is loss of analytes. Sampling strategy and preservation. Sampling is collecting a certain volume of a water body to be studied with the smallest possible amount, but still representative and still has the same characteristic as the water body. Sampling is divided into the following tier varieties. One is representative sampling, and the second is transport and preservation of samples and sample chemical analysis. Preparation of sampling and its preservation. One is the bottle. The bottle that will be used to take a sample must be clean and have been rinsed with distilled water first, then followed by the liquid that will be used to fill the water and dry if possible. We have to think about the cleanliness of the sample container in order to get the correct concentration result without any chaos from the analysis bottle. Second, the sample applies to sampling equipment such as pipes, pumps, and etc., which must be clean and free from residues from the old sample, especially the growth of mold and mildew must be prevented. Contamination from metals or sampling equipment which may dissolve in the sample must be prevented. Iron, brass, bronze can be dissolved in acidic or basic water, while plastic and rubber materials can be dissolved in industrial wastewater containing organic solvent or oil and gasoline. Samples can be taken separately using a bucket, plastic or glass powder. It opened at wide, for example, with a lead ring around the neck, tied with a rope, then put into rivers, canals, wells, and so on. Taking sample a certain tape is suction pipe. The tip of the sampling point is limited to about 5 meters below the tool. Second is palm, ours to control sampling frequencies, tool for giving sample to bottle for mixed sample. Isothermic box containing bottle of the mixed sample with cooling by ordinary ice or dry ice, so that sample preservation can be carried out no later than 1 day before being brought to the laboratory. The sample should fill the collection file completely, and the file should be tightly closed to avoid contact with air. One common way of preserving sample is the cold atmosphere. Samples are transferred in an isothermic box containing ordinary ice or dry ice, carbon dioxide, and then stored in the refrigerator or freezer. Contamination analytes. Contamination is defined as an entry of unwanted compounds into the sample during the sample pre-treatment process and during analysis. 1. Contamination from the atmosphere, primarily driven from particularly trace elements on the soil surface and spent materials in the atmosphere. The simplest way to avoid atmospheric contamination of the sample is to cover the sample solution during the preparation and analysis process. Number 2 is contamination by operator. Analysis can be source of contamination of the sample to be analyzed, either through direct contact or through the air. Na, natrium and chloride can be natrium and chlor can be transferred to the sample through the operator's breath. This and cigarette smoke is no source of metal contamination. And then powder, lotion, perfume, including operator clothes and shoes, and etc. and etc. can be source of contamination. Human skin is reported to contain metal even in very low concentration. Masks, gloves in the laboratory coats are usually worn to reduce contamination. And then contamination analysis. Contamination from equipment. Number 1 is glassware. For example, Pyrex and silica glass. We must washing glass using one mixture of concentration, sulfate acid and HNO3 is better than mixture of Tier2O7 and sulfate acid. The second is fluted silica. We know that we can call that quartz. And then plastic is polyethylene and polypropylene. 4 is Teflon, is tetrafluorethylene polymer. And 5 is PVC, polyvinyl chloride. And the 6 is rubber. Contamination from water. Contamination from water is science is used in very large quantities compared to the reagent having ratio 100%. It is necessary to pay special attention to the purity of the water used, especially in trace analysis. To reduce metal contamination in water, the water needs to be passed first into the ion exchange reagent column or at least 2 times distillation. This is contamination from reagent. The first is mineral acid and ammonia. What is mineral acid? Mineral acid is the most mineral acid contains certain amounts of metals. And this mineral acid, we know that have an extra pure acid. It contains metal in a very low levels. Generally, reagents of this quality are quite expensive. And then ultra pure. Generally contains very low metal concentration, but the content of some elements varies from product to product. And then analytical reagent grade acid is usually contain metals in accordance with those listed in the table which are within impurity. The second is ammonia. Ammonia solution in the water placed in a glass bottle will be contaminated by silica, aluminum, calcium, and other elements that may be caused by attack by alkaline solution on the glass. Analytical reagent ammonia can contain heavy metals with fairly low concentration. For zinc is 0,00 ppm and Pb, and then Cu. This is probably due the absorption of the metal by the glass. The next is inorganic solid. Inorganic solid of reagent quality are usually sufficiently pure to be used directly without the pre-purification, but a blank counter solution must be prepared. And therefore, example, lead Pb is an important metal. In this metal content is usually found in solid is calcium chloride, natrium chloride, and the others. And then the next is organic reagent. Organics, cladding reagents. You can call clad agent is usually contain a coordinately bonded metal. The metal being usually derived from the solvent or reagent used in the synthesis of the ligand. The last is organic solvent. The metal content in the solvent is usually relatively low, which must be watched out for is the presence of other organic compounds dissolved in the solvent because it usually interferes with the spectrometric determination. For example, is CCl4 and the other. If left uncovered with porous usual oxidation result, which will interface with the determination of metal by the Dickson method. Loss of analytes. In the preparation, separation, and determinant stage, the analyte can be removed from the sample solution by the following factor is adsorption, volatilization, and co-precipitation or precipitation. Okay, that's all my presentation. I'm sorry if there are some mistake. Thank you for attention and wassalamualaikum warahmatullahi wabarakatuh.